In our normal life, we use different types of sensors that are commonly used in various applications. All these sensors are used for measuring one of the physical properties like temperature, resistance, capacitance, conduction, heat transfer, etc. In this video, we have seen different types of sensors along with their practical applications. There are a few types of sensors such as temperature sensors, infrared sensor, proximity sensors, pressure sensors, level sensors, smoke and gas sensors. Ultrasonic sensors and touch sensors are commonly used in most of the electronics application. Temperature sensors. A temperature sensor is a device, typically a thermocouple or RTD, that provides for temperature measurement through an electrical signal. In other words, a temperature sensor is a device that detects and measures hotness and coolness and converts it into an electrical signal. There are different types of temperature sensors like LM35 IC, thermistors, thermocouples, RTD, etc. Temperature sensors are used everywhere like computers, mobile phones, automobiles, air conditioning systems, industries, etc. IR sensors. An infrared sensor (IR) is an electronic device that emits in order to sense some aspects of the surroundings. An IR sensor can measure the heat of an object as well as detects the motion. These types of sensors measure only infrared radiation rather than emitting it, that is called as a passive IR sensor. Different applications where IR sensor is implemented are mobile phones, robots, industrial assembly, automobiles, etc. Proximity sensors. A proximity or presence sensor is the one which is able to detect the presence of nearby objects without any physical contact. They usually emit electromagnetic radiations and detect the changes in reflected signal if any. Proximity sensors are also used in machine vibration monitoring to measure the vibration in distance between a shaft and its support bearing. This is common in large steam turbines, compressors, and motors that use sleeve-type bearings. Pressure sensors. A pressure sensor is a device for pressure measurement of gases or liquids. Pressure is an expression of the force required to stop a fluid from expanding and is usually stated in terms of force per unit area. A pressure sensor usually acts as a transducer. It generates a signal as a function of the pressure imposed. Pressure sensors can also be used to indirectly measure other variables such as fluid or gas flow, speed, water level, and altitude. Level sensors. A level sensor is one kind of device used to determine the liquid level that flows in an open system or closed system. The level measurements can be available in two types, namely continuous measurements and point level measurements. The continuous level sensor is used to measure the levels to a precise limit, but they give correct results, whereas point level sensors used to determine the level of liquid, whether that is high or low. Ultrasonic sensors. An ultrasonic sensor is an instrument that measures the distance to an object using ultrasonic sound waves. An ultrasonic sensor uses a transducer to send and receive ultrasonic pulses that relay back information about an object's proximity. Ultrasonic sensor can be used for measuring wind speed and direction, tank or channel fluid level, and speed through air or water. Smoke and gas sensor. A smoke detector is a device that sends smoke, typically as an indicator of fire. Commercial security devices issue a signal to a fire alarm control panel as part of a fire alarm system, while household smoke detectors, also known as smoke alarms, generally issue a local audible or visual alarm from the detector itself. Touch sensors. Touch sensors are also called as tactile sensors and are sensitive to touch, force or pressure. They are one of the simplest and useful sensors. The working of a touch sensor is similar to that of a simple switch. When there is contact with the surface of the touch sensor, the circuit is closed inside the sensor and there is a flow of current. When the contact is released, the circuit is opened and no current flows. Touch sensors are used in a wide range of display applications, from smart homes and appliances to security and industrial solutions.
Fire alarm systems are designed to alert us to an emergency so that we can take action to protect ourselves, staff, and the general public. Fire alarms are found in offices, factories, and public buildings. They are a part of our everyday routine, but are often overlooked until there's an emergency, at which point they might just save our lives. Whatever the method of detection is, if the alarm is triggered, sounders will operate to warn people in the building that there may be a fire and to evacuate. The fire alarm system may also incorporate a remote signal system, which could then alert the fire brigade via a central station. In this video, we will have a look at the structure and types of the fire alarm systems. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. The brain of the system is the fire alarm control panel. It is the central hub for all of the detector signals to be wired to, and provides a status indication to the users. The unit can also be set up to simulate an alarm for use in routine fire and evacuation drills, so all staff knows what action to take in the event of a real fire. At the core of a fire alarm system are the detection devices, from sophisticated intelligent smoke detectors to simple manually operated break glass units. There are a wide array of different types, but we can divide them into groups, including heat detectors, smoke detectors, carbon monoxide detectors, multi-sensor detectors, and manual call points. A heat detector can either work on a fixed temperature basis, where it will trigger an alarm if the temperature exceeds a preset value, or they can work on the rate of change in temperature. Commonly, heat detectors work in a similar way to an electrical fuse. The detectors contain a eutectic alloy, which is heat sensitive. When a certain temperature is reached, the alloy turns from a solid to a liquid, which in turn triggers the alarm. There are three basic types of smoke detectors, including ionization, light obscuring, and light scattering. An ionization smoke detector generally contains two chambers. The first is used as a reference to compensate for changes in ambient temperature, humidity, or pressure. The second chamber contains a radioactive source, usually alpha particle, which ionizes the air passing through the chamber where current flows between two electrodes. When smoke enters the chamber, the current flow decreases. The drop in current flow is used to initiate an alarm. The light scattering smoke detector operates on the Tyndall effect. A photocell and light source are separated from each other by a darkened chamber, such that the light source does not fall on the photocell. The passage of smoke into the chamber causes the light from the source to be scattered and fall on the photocell. The photocell output is being used to initiate an alarm. In the light obscuring smoke detector, smoke interferes with a light beam between a light source and photocell. The photocell measures the amount of light it receives. The variation in photocell output is being used to initiate an alarm. This type of detection can be used to protect large areas, with a light source and photocell positioned some distance apart. Carbon monoxide detectors are also known as CO fire detectors, and are electronic detectors used to indicate the outbreak of fire by sensing the level of carbon monoxide in the air. Carbon monoxide is a poisonous gas produced by combustion. In this instance, these detectors are not the same as carbon monoxide detectors used in the home for protecting residents against carbon monoxide produced by incomplete combustion in appliances such as gas fires or boilers. Carbon monoxide fire detectors use the same type of sensor as those in the home, but are more sensitive and respond more quickly. Carbon monoxide detectors have an electrochemical cell, which senses carbon monoxide, but not smoke or any other combustion products. The multi-sensor detectors combine inputs from both optical and heat sensors and process them using a sophisticated algorithm built into the detector circuitry. When pulled by the control panel, the detector returns a value based on the combined responses from both the optical and heat sensors. They are designed to be sensitive to a wide range of fires. A manual call point or break glass call point is a device which enables personnel to raise the alarm by breaking the frangible element on the fascia. This then triggers the alarm. Fire alarm systems can be broken down into four main types: conventional, addressable, intelligent fire systems, and wireless systems. Let's spend some time considering each. In a conventional fire alarm system, physical cabling is used to interconnect several call points and detectors, the signals from which are wired back to the main control unit. Call points and detectors are arranged in zones to simplify locating the cause of the alarm. This is important for both the fire brigade and general building management. Each zone is indicated at the fire alarm control panel either with an indicator lamp, a text display, or in some cases both. It makes sense that the more we can divide a building into zones, the more accurate locating the alarm trigger will be. The control panel is wired to a minimum of 2 sounder circuits, which could contain bells, electronic sounders, or other audible devices. It is these devices which sound the alarm when triggered. The detection principle of an addressable system is the same as a conventional system, except that each detector is given a set address, usually by means of a dip switch. And the control panel can then determine exactly which detector or call point has initiated the alarm. The detection circuit is wired as a loop, and up to 99 devices may be connected to each loop. It is common for the loop to be fitted with loop isolation modules, so that the loop is sectioned in order to ensure that a short circuit or single fault will only cause the loss of a small part of the system, allowing the rest of the system to function normally. In the previous two systems, the conventional system and the addressable system, the detectors are not considered intelligent, as they can only give output signals representing the value of detected phenomena. It is left up to the control unit to decide whether there is a fire, fault, pre-alarm, or other. However, in our next type of system, which is an intelligent fire alarm system, each detector effectively incorporates its own computer, which evaluates the environment around it and communicates to the control panel whether there is a fire, fault, or the detector head needs cleaning. Essentially, intelligent systems are far more complex and incorporate far more facilities than conventional or addressable systems. Their primary purpose is to help prevent the occurrence of false alarms. Intelligent fire alarm systems are available in 2, 4, and 8-loop versions, which means large premises can be monitored from one single panel. The final type of system we will consider is the wireless fire alarm system. These are an effective alternative to traditional wired fire alarm systems for all applications. They utilize secure license-free radio communications to interconnect the sensors and devices with the controllers. It is a simple concept, which provides many unique benefits and is a full intelligent fire detection system without the need for cabling. In this video, we have learned that fire alarm systems are fitted in many buildings we encounter every day, and that they are used to warn people within the building of an emergency fire-related situation. We discussed the main types of detectors: heat detectors, smoke detectors, carbon monoxide detectors, multi-sensor detectors, and manual call points. And finally, we looked at the different types of fire alarm systems: conventional, addressable, intelligent fire systems, and wireless systems. We hope you enjoyed this short